In this video, we're going to look at how we can use the TI-89 to do some calculus. So the first thing that you learn in calculus is limits. So let's take a look at this limit and let's see how the calculator can go about helping us evaluate this limit. So here's our calculator. You might notice at the top there are some menus. We talked about the algebra one in the previous video. Let's look at the calculus menu in this video. So when you hit F3, you can see that you can move down here to number 3. You could also type number 3, hit enter, and that's going to bring up our limit. And then we need to put in our function. It was a rational function, you guys should remember. Let's take a look at it. So that means that when you put in the numerator and the denominator, you should put parentheses around that. And once we finish the limit and hit enter, you'll be able to see what the calculator is actually calculating printed in a nice way, so you can compare that function to what you're supposed to be doing. So we put in the limit, we put in the function, and now we have to tell the calculator what variable we're using. In this case it is x, so I put comma x as the second of the terms of the limit, and then I have to say what it was approaching. It is approaching 3, so I'm going to put a 3, close that, and now you can see that this all is what we were looking for here. You can see that the limit is approaching 3, and that is the function we got, and 15 over 22 is the limit. Okay, let's take a look at another limit. Not that one, that's the one we just did. Let's take a look at this one. Limit as x approaches 0 of 3x minus 1. If you remember from calculus what was going to happen here when you directly substitute, you're going to get that this limit does not exist. So let's see how the calculator handles this. So I'm going to clear out that. I'm going to go to my F3 menu, down to limit. I'm going to type in 3x minus 1 divided by x, and it was approaching 0, close the parentheses, and you can see that it says it's undefined. That's the calculator's way of saying that the limit does not exist. Okay, let's take a closer look at one of these ones where the limit does not exist. Let's do this limit. Okay, so we'll do, I'm just going to hit the 3 there. It's going to bring that up. 1 divided by x minus 3, x, 3. And you'll notice that when I did this, because I didn't put parentheses around the denominator, it doesn't look right. So I'm going to go back down here. I'm going to use my arrow keys to get in place, put in those parentheses so I can actually get the limit that I want here. You can see that that's undefined, which is what you should expect. So now what I want to do is take a look at what would happen if I wanted to do the limit as x approaches 3 from the right. How would I type that in on a calculator? So to do that, I'm going to keep everything there the same, but at the end, to approach from the right, from the positive side, I'm just going to put in a positive 1. Okay, putting in a positive number here tells it that it's coming from the positive side, and you can see that the answer that you get there is infinity. Okay, if I approach from the negative side, I'm going to put in a negative 1, and then I hit enter, and you can see that that's going to give me negative infinity. Okay, notice though that what we're not doing, we're not putting in a number that represents anything on the x-axis. That negative 1 does not mean a negative 1 plotted on the point and approaching from that number. It just is simply telling you that's coming from the negative side or the positive side. Okay, if you think about approaching 3 from the right, if we go back up to this one, approaching 3 from the right, you wouldn't be coming from the number 1. So the 1 just tells it to come from the positive side from the right. Okay. All right. The next thing that I'm going to look at is, well, if we can get infinity as an answer, can we approach infinity for our function? So let's go here. Let's go to F3 and limits. And then it was parentheses 2x plus 3 divided by x minus 2, close the parentheses, comma, x is our variable. And then to get infinity, I will zoom in on the keyboard here. And then infinity is the green on catalog, so I'm going to type in green catalog, and you can see that that's going to give me the infinity symbol. I'm going to close my parentheses, and you can see that I get 2 as an answer. Okay. Similarly, I can approach negative infinity, so let's look at this function. If I do the limit as or of the function square root, you can see the square root puts in the parenthesis there, plus 2x, close the parentheses, plus 3x. X is my variable, and then negative, make sure you use the negative sign and not a minus sign, or else you'll get a syntax error. And then catalog, close the parentheses, and you can see that you get negative 1/3 as your answer. So that's limits. Let's move on to the next thing. Let's say that we wanted to find the derivative. We're just going to keep these pretty simple. Derivative of x squared. So the way you would do that on the calculator, maybe you already saw it under the menu here for calc, is differentiate. So you're going to hit that, type in x squared, and for all of these calculus things, you have to put a comma x to tell it what the variable is. And you can see when you do that, it gives you 2x. If I were to, just for an example, put in a different variable, it's going to give me 0, because it's going to treat x squared as a constant. The derivative of a constant is 0. So when you take the derivative with respect to t, and you can see that says d dt instead of d dx. Okay, so that's how you can take the derivative. Let's do another, a little bit more complicated example so you can see that it'll do it. Let's look at the derivative of the square root of x times cosine of x. And at this point, I also want to show you that you don't have to use the F3 menu to get it. You can actually, you can hit escape to close the menu. If you look at the 8, you can see that there is a little blue D. That is the derivative. So if I do second and then 8, that's going to bring up the derivative sign. And now I can take the derivative of my square root of x. I'm going to close the parentheses on that, times cosine is of the z of x. Got to tell it what the variable is. And you can see that not only does it say exactly what I'm taking the derivative of, that it finds the derivative down there. You would use the product rule, if you remember from calculus. All right, moving on. What if I want to take a second derivative, a derivative of the derivative of x to the 4th? That's one way to write it. Another way to write it is like this, and you'll see that that's how it comes up on the calculator. So on the calculator, what we're going to do is we're going to do, well, we could do it as the derivative of the derivative of x to the 4th, comma x, close the parentheses on the first one, close the parentheses, or comma x again, close those parentheses. And you can see that that is the derivative of the derivative. But there's a shortcut. If I just do the derivative of x to the 4th, and I tell it the variable, I can add another entry into this function, and I can say take the second derivative, so I'll use a 2 for the second derivative, close those parentheses, and you can see that that comes up as d squared dx squared of x to the 4th, which gives us the second derivative. The last thing I want to show you is that you can actually take these derivatives so that the calculator will evaluate the output at a certain point. So if you're reading this, it says the derivative of x to the 4th evaluated when x equals 3. Basically, you're taking the derivative, you're plugging in 3. On the calculator, the way you could do that is you could take the derivative of x to the 4th. I'm going to tell it the variable is x. And then I'm going to use that same evaluation bar that we used previously. And I'm going to say that I'm going to evaluate this when x equals 3. Okay? And that will tell you that it is 108. It'll taking the derivative and then evaluating it when x equals 3. Okay? So that's derivatives. And finally, the last thing that we should know how to do in calculus is integrals. So let's take a look at a very simple integral. Let's do the integral of x squared dx. Back on the calculator, if we go to the calc menu, the second thing there is integrate. So I can select that and I can type in x squared. And I need again to tell it that the variable is x, close the parentheses, and you can see that it's going to give me the integral of x squared dx. Now you'll notice that this is an indefinite integral, which means you get a function that is the antiderivative, but you should also notice that while it does give me the antiderivative, it does not include the plus c. So that's on you guys to remember that when you do antiderivatives, you have to have a plus c. So that's indefinite integrals. Calculator can also do definite integrals, which you'll remember hopefully look like this, where there are bounds, numbers that x is going from 2 to 5. This means the area under the curve, basically. So you can type that in. Before I do that, though, I do want to show you that just like the derivative had a shortcut key here above the 8, the integral shows up above the 7, so I can do blue and then 7. And that's going to give me the integral symbol, so I can now type in my function, square root of x minus 1, close the parentheses. I got to tell it the variable. And if I just close the parentheses here, it would give me the antiderivative. But if I continue and put in two more things, I can put in the lower bound and then the upper bound. It's going from 2 to 5, so I do those in that order. And it's going to tell me that the answer is 14/3. Maybe you don't want the fraction, maybe you want decimal approximation. So you'll remember from the previous video, one way to do that is to just add in a decimal point on one of the numbers and it'll give you the decimal approximation. The other way to do it is you could use the green diamond and then hit enter, and you can see the little approximately equal to. Nice thing about these calculators, and we really haven't seen all that it's capable of, but one of the things this calculator can do is it can evaluate something like the integral of kx, where k is just some number, some variable that we don't know, some constant. And so we can just type that in. So if I do the integral of k, and the way you can get a k is by finding the alpha, and it's on the EE here, k times x, comma, x is the variable. It will treat k like a constant and give you k times x squared over 2. And that works if you put bounds in. Let's say that we want to go from 1 to 5. It'll tell you that the answer is 12k. And even if you wanted to, you could actually put in k as one of the bounds and in the function itself, and it'll figure out what that is going to be as well. So these calculators are pretty powerful. They can do computations with variables, constants in the function, as well as the actual numerical calculations. So that is using the calculator to find limits and derivatives and integrals.